Al Coles. We met at PME last year with Carolyn, and talking to him, he said he was coming to ARA, and it just worked out that he'd be here today. He's a senior lecturer in education at the University of Bristol, and he taught secondary school for 15 years. And we can talk to you today about this. So, thank you.
Thank you very much. Well, it's a great honour for me to be here, and I want to particularly thank Carolyn and Robert for inviting me and arranging everything. I guess I also hope that this might be the beginning of some ongoing work and an ongoing collaboration. So, as Robert said, my background is in teaching. I taught in what we would call secondary schools in the UK, so that's for students aged 11 to 18, and I taught mathematics for 15 years. At the same time, researching initially my practice and then also the practice of other teachers in the department where I worked. So I guess I've been involved in researching mathematics classrooms for close on 20 years. And I've been at the University of Bristol for the last 3 or 4. So I'm hoping to work with you for about 45 minutes at the beginning, and then leave some space for discussion at the end. And I'm conscious, as well as having said a little bit about myself, to perhaps say something about some of these names. I'm assuming Bob Davis is familiar to everyone, but Dick Tarter and Caleb Gattegno perhaps less so. Here's a sort of family tree, of course, with many names missed out. Arthur, would you put your line direct to Caleb Gattegno, or would you go through Bob Davis? Or?
Well, direct to Gattegno, but also to Dick.
And to Dick, okay. So I suppose one of the things that interested me is that, and maybe Arthur's a case in point where he's crossing it, is this sort of US sort of side and UK side perhaps. And of course, John Mason slightly crosses as well. So Caleb Gattegno, I think Arthur's written an article about the greatest African educator. Very influential figure who inspired the use of the Cuisenaire rods. So I'll be talking a little bit about those later. Some of you may know about those sort of wooden blocks that at some stage were very common in the UK. And he certainly influenced Bob Davis. And also Dick Tarter, I guess, was probably Caleb Gattegno's closest collaborator in the UK. And I got to know Dick Tarter through Lorinda Brown, who I've worked with for the last 20 or so years, or 15 or so years, thinking about teaching and learning in maths classrooms. Dick Tarter left his mathematical papers to Lorinda and myself, and I'll be drawing on some of those sort of private papers a bit later. And in fact, the title of the talk comes from one of those private papers. And John Mason, I guess, is a name familiar to many of you as well. So I guess part of why I'm excited to be here is, forging more links between these two sides of the family tree, perhaps. Okay, so this is probably familiar to many of you as well. One of the ways I first got to know about Bob Davis's work was through the Madison Project. And here's a statement of the mathematical aims. There were other aims as well, but I'll just give you a moment to read those from 1965. So I guess the one I'm particularly interested in is number 3, and again that will link perhaps to the title of the talk. Acquire a set of mental symbols, interestingly mental, not necessarily mathematical, mental symbols that will let him, think creatively about mathematical situations. So I'll come back to that, but I just want to flag that one up. And the other thing that interests me is that the word understanding doesn't appear anywhere in these aims. So, wrong thing, I've got 2 screens, this is the one I need. So, I suppose the key questions I want to think about today, how can we make the learning of mathematics efficient? And it seems to me that's one common concern across the work of Gattegno, Dick Tarter, and Bob Davis. Efficient in terms of time. And I think the all is very important for all the students that we teach. So, I see amongst the work of those 3 educators I've talked about, quite a real concern with social justice. I think we know that performance in mathematics is one of the key differentiators of sort of life chances, certainly in the UK, I'm imagining in the US as well. And so actually, it's a very real issue of social justice to find ways of making mathematics accessible to all students. So, yeah, another way of saying that maybe, how do we learn mathematical concepts, and how do we learn them fast? How can we learn them quickly? And I want to say, and I'll say it again, I'm not talking about rote learning here. So we'll come back to that distinction maybe later. So something from the journal that Carolyn edits, a very helpful thing. Obviously, a lot has been written about how we develop mathematical concepts. So here was a table by David Tall and others looking back over 50 years of research about the development of mathematical concepts. So again, I'll just give you a moment to scan through that. And I guess a couple of things kind of strike me here. One is, I mean, I guess it's the way they set it up, but I think it is there in all the authors as well, a strong sense that in the development of mathematical thinking, development of mathematical concepts, there's this move from process to some kind of object view over here. I mean, obviously in David Tall's work, he feels the process is still around, but still a movement from a process only to something here where there's objects and possibly processes as well. Yeah. So I guess it's only at that right-hand side of the page that maybe we actually, these authors would say we actually have the mathematical concept. So we start with the process, there's the concept there. So I guess that shifts the question a little bit to thinking about, okay, so what if we accept that? What are the useful processes on the left-hand side of the table we can be engaging students in so that they can move quickly over to the right? And again, I'm particularly interested in the role of symbols in supporting that shift. That took us up to the 1990s, and just very briefly, because I'm kind of conscious of time, just a very partial look at some of the themes in maths education since 2000. And I want to particularly highlight two sort of terms they're sometimes called. One would be linguistic, Candy Moore and Richard Barlow, many others working on this, and a sense that meaning isn't just this thing going on inside people's heads. So I think part of the linguistic turn was a move away from a cognitive view, particularly, and actually trying to stay relatively silent about issues of cognition and trying to see meaning as arising through dialogue. And the other turn, the embodied turn, I placed myself within the sort of worldview of enactivism, and that's got many different routes, but a sense of cognition arising out of interaction. So perhaps a very simplest example from biology. If you imagine an amoeba being placed in a sugar solution, the amoeba will swim or move up the gradient, up the sugar gradient. From an enactivist's perspective, that is one of the very simplest examples of what cognition is. So we would want to say that's an example of cognition. What that amoeba is doing is, in a sense, giving value to its world. That meaning, that this sugar solution becomes meaningful. It's not meaningful on its own. The amoeba on its own isn't meaningful. Put the two together, and through their interaction, there is a very simple but very proto example of giving the world value of meaning. Again, I'm conscious of time. I don't particularly want to say more about that now. But if people have got questions about other implications of the enactivist worldview, then I'd be happy to answer that later. And in fact, if you are interested in that, in 2015, a little plug here, I'm working on a special issue of ZDM with a group of others looking at enactivism as a methodology within maths education. Okay, so taking those language and embodied perspectives, again, the question is perhaps reworked once more. How can students be supported to enter into mathematical discourse? Would be the sort of linguistic way of saying that, and again, how can that happen quickly? Or how can students be supported to take effective actions? From an embodied perspective, knowing and doing are really synonymous. Okay, so given any of those views on concept development, there have been, from antiquity really, many articulations of difficulties or paradoxes in learning. Even going back to Plato, there's this lovely bit in the Meno, I think. How will you look for it, Socrates, this thing that you don't know what it is yet? And how will you know that you found it when you come across it? St. Augustine, a few centuries later, talking particularly about symbol and sign use, there's nothing to be learned by the signs proper to it. So the kind of idea, my interpretation of his idea here, was that if I try and teach you something through only using words, then either you know what I'm referring to, and so you don't need the words to be attached to that, or else you have no idea, or else you don't know what I'm talking about, in which case the word's not gonna get you to that. So again, I think a sort of similar way of saying the same thing as Plato. I emailed Paul, this is Paul Ernest, I emailed Paul Ernest last week and I said, Paul, do you remember that amazing thing you wrote about the difficulties between bridging the concrete and abstract? And he wrote back a few days later saying, I've racked my brain, racked my hard drive, I can't find it. But I'm sure he did write this, so I'm sure this isn't me. But Paul Ernest somewhere, I think, wrote about the dilemma of offering students concrete models of mathematical concepts. And what my memory is of what he wrote about, that you offer this concrete model for this mathematical concept, and it kind of makes sense if you've got the concept already. Then you can see the links, you can see the connections, but it's not at all obvious that without the abstract concept, that the concrete one will help you get there. Again, another way of saying the same paradox. And Anna Svard at PME last year, this was in her presentation, not actually in her paper, to participate in a discourse on an object, so she's coming from this language view of learning, you need to have already constructed this object, but the only way to construct an object is to participate in a discourse about it. So in some sense I see those as all different ways of saying the same thing. And one source perhaps of these problems is the view that what we're talking about here is something individual, that concept development is about gaining something, owning something. And there's a quote I am going to read because I love it so much, from Dick Tarter, again in his private papers, and talking about this kind of ownership view of learning. This, meaning this ownership model, this then inevitably leads to metaphors of ownership and control. Obtaining the meaning, having the understanding, getting the concept. And consequently, of course, there will be the mathematical deschaminados, the shirtless who have not understood, who never get the concept. Whereas I always have some concept of what we may both be considering, I will certainly never have yours. And I think there's something incredibly powerful in that statement, that perhaps actually this focus on understanding and students really needing to get this is part of what's causing this sort of divide, that some people never get it. In the UK, my youngest daughter, when she was aged 4, in her first year of school, the teacher once stated to me, yeah, Iris is actually being taught maths just in a little group on her own, for those people who've not quite not quite up with their peers. And this was aged 4. And certainly, again, in the UK, there's evidence that once you're identified as being somebody struggling with maths, you're placed in a set. That means you're very unlikely to ever get out of that. Joe Bowler would say you're not offered a curriculum that allows you to get out to move on. And we know that life chances, again, are linked to mathematical achievements. So for me, the social justice element of the question of how do we make maths learning effective, again, comes to the fore here. Okay, so those are all the kind of precursors, I guess. And what I want to do now is look at 2 short video clips. One from Bob Davis, one from Caleb Coutinho. Unfortunately, I don't think there's any video of Dick Tarter teaching. And I guess what I'm interested you reflecting on how they use symbols and how they connect symbols to the concrete. Okay? So both the clips just last for a couple of minutes. I'm just going to play them, and then I'm going to ask you in pairs or threes to just talk a little bit about this question about how they link the symbolic to the concrete. Okay, and we'll do one of discussing and then do the other. So I'm indebted to Robert for handing me or giving me the link to this clip. I don't know when it is. It's early. I don't know what age the kids are, but I guess probably they look about 5 or 6 to me. And if any of you know the Video Mosaic archive, you'll probably recognize the activity. Okay. I think that's all I want to say. So we're thinking about linking the symbols to the concrete. Next. I was going to say one more thing. When you get to discussing it, what I'd like you to do is just to begin, try not to interpret it straight away. So when you begin discussing it, try and just agree on what happened and the order on which it happened. Just try and stay with the detail. John Mason would call it try to give an account for what happened, and trying to leave the account of it till later. But just what do you see?
Tell us when to start, and you say go.
Go.
Okay, Jeff said go. And I'm going to put 3 stones in the bag that Nora is holding. I'll put 3 stones in. Are there more stones in the bag now, or less than there were when Jeff said go? Charlotte, what do you say? More. And how many more, if you didn't all know? How many more? Laurie, how many more? 3 more. Okay, and now I'll take some stones out of the bag. How many stones do you want me to take out of the bag? Barbara, how many stones do I take out?
3.
3, I'll take 3 out. Okay. Barbara said take 3 out, so I'll take 3 stones out. There's 1. There's 2. There's 3. Take 3 stones out. And I better write that. Took 3 stones out. Now are there more stones in the bag than there were when Jeff said go, or are there less? Fred?
These are the same amount.
It's the same amount. I bet that's right. And what will I say here, if you didn't know? What will I say?
Oh, yeah.
Sandy, what will I say?
0.
0.
Now,
Right. Okay, that was that time. I need 2 other assistants. Thank you very much.
Oh,
I need somebody to come hold the bag. Paul, will you come hold the bag? And I need somebody else to come and say when to start. Bruce, would you come? Okay. You're going to tell us when to start. Good. Go. Bruce said go. How many stones do you want me to put in the bag? Can't see how many. 5. Okay, I'll see if I've got 5. Yeah, turns out I've got 5 stones here. I've got 5. Got 5 stones there. And so I'm going to put all 5 of these in the bag. And I better write that before I forget. Are there more stones in the bag than there were when Bruce said go, or are there less? Jeff?
more.
And how many more?
5.
5 more, huh? Okay, how many do you want me to take out? No, how many will I take out?
5.
I don't want to do that. Some other number. 6? Oh, I'll take 6 out. What's that up? Take 6 out. I've done it, haven't I? Won't be able to do this if I didn't. Let's see. 1, 2, 3, 4, 5, 6. That's the management. I got exactly 6. Okay, I'll write it. Have I got more stones in the bag than I had when Bruce said go, or have I got less? Yeah, less. And maybe not how many less. Nora, how many less? 1 less, okay. And how will I write this 1 to show that it's 1 less? Gary, how will I write? -1. And that's just what I'll do. Let me do that once more.
Okay. So in a moment, I'll ask you to get yourself into small groups. The question is how is he linking the symbols to the concrete objects? But as I say, I'd invite you to begin just by trying to agree on the sequence of things that occurred there. Try and agree on the detail of what happened. We can replay some bits of it if you're not sure or quite how it was organized. And then we're thinking about the use of symbols. Okay, so maybe 3 or 4 minutes in 2s or 3s. and we'll get some feedback.
The second one.
So, any reflections? So it could be any bits where you actually disagreed on what happened, or it could be any reflections on this symbol concrete link. Any bits of feedback from the group? Yes.
One thing that we thought was interesting was that what the sign means is different whether it's on the left side of the equal sign or the right side. So like on the left side of the equal sign, the sign means the number that was taken out, -3. On the right side, it means...
I like this one to show that it's one less.
Is this what you're talking about?
Right, well, yeah, so in this case, the negative 6 on the left side means they took out 6. The negative means I took out.
Yeah.
Right? But on the right side, it means how many fewer were there than when we started.
Nice. And one thing, in fact, Karen and I were talking about on the way in is that in Bob Davis's work, you might notice that there's a distinction made between taking away and negative. And so one is smaller and slightly superscript to try and make that distinction. Mm-hmm. Any other bits of feedback from the group? Particularly, yeah, other role of symbols. Yeah.
Bob found a way to engage the students in the process of giving meaning to the symbols by how he interacted with them, essentially got them to take on an active role in the process.
Yeah, I mean, I think that sense of the process seems really important to me. The thing I want to, for me, draw out is that these symbols aren't directly talking about the stones. So that 3 doesn't directly mean 3 stones. It means 3 more stones. Or it means 3 stones added. So for me, one thing that is really significant here is the symbols are referring to actions on the concrete objects, rather than the concrete objects themselves. And I've got one more video of Gattegno where I think a similar thing is happening. So the plus and minus are actions on the stones, and yeah, as I say, the number symbol is a change. So it's not that 3 stones is 3, but that 3 is representing a change in number of stones. Okay, one more video clip, and again, a similar thing. So this is Caleb Gattegno teaching. I think probably in Canada. Yeah, right. These are first grade students. And he goes on to work with them on fractions. You may just see at the end here, it's a bit blurred, these are the Cuisenaire rods, so they're blocks, you need to know a little bit about this to make sense of them. They're blocks that are differently coloured. The white block is 1 centimetre square, the red block is square based but 2 centimetres long, the green block is 3 centimetres long, and so on. Okay? And up to this point, they've been working on relations between these rods, referring to them by their colour names. So orange is the largest one, so working on greater than, less than with colour names. And Gattegno here shifts it. We're just going to watch a very short bit. Again, I'm interested in the link between the symbols and the concrete objects.
Good. Now, let's find new names if we call the white one 1. If the white one is 1, what's the name of the red?
2.
And the light green?
3.
And the purple?
4.
And the yellow?
5.
The dark green?
6.
The black?
7.
The brown?
8.
The orange?
9. 9.
The orange?
10.
And the blue?
9.
Now let me see whether you can find which picture, how many white ones will go into this. Say it.
7. 1.
Into this.
3.
Into this.
2.
Into this.
8.
Into this.
9.
Into this.
5.
Into this.
6.
Into this.
7.
Into this.
9.
Into this.
10.
Into this.
19.
What is it?
19.
Into this.
19.
Into this.
19.
And into this.
19.
Well, now
Okay. So again, just a couple of minutes in your pairs. What happened? How is the symbol? There were no written symbols at this stage. The verbal symbols. How are the symbols linked to the concrete objects? A couple of minutes in your same groups you're in. Lovely. Okay, some really nice reflections there. What I want to draw out is something about linking again. So this Bob Davis, a sense that his symbols are talking about actions on the stones. And I think for Gattegno, what I see as really significant is that he begins that clip saying, we're going to get some new names for these rods if we call the white one 1. So this is the first time that he's introduced numbers with this class. And the number, the red rod, that's 2 centimeters long, is not 2. The red rod is 2 1s. It's 2 whites. So number is again being introduced as a relation between the rods. And so I see quite a strong similarity here between what Bob Davis is doing, that number in Bob Davis is an action on the stones. For Gattegno, number is a relation between the rods. And very quickly, Gattegno gets them working with fractions. So if you could imagine, say, 3 white rods placed against the green one, and that's his image for 3, it's 3 1s, that equally is an image for a third. So the green rod is 3 of the white, and the white rod is 1/3 of the green. And he works with those simultaneously. And again, there seems to me something very powerful here that links back to the theme of how do we make mathematics learning quick. With the Bob Davis, by not tying the symbols directly to the stones, he's able to introduce negatives with seemingly no problem. I showed that little video clip to a group in Bristol, and there was an experienced primary school teacher from, I can't remember which country, anyway, doesn't matter, from another country, who was just kind of in shock because all her life she has believed you can't really work with negative numbers with children before they're about 8. This is an incredibly difficult concept. And here, just the ease with which Bob Davis gets them seemingly using that negative 1, I see as linked to the way the symbols are arising out of the concrete objects. And again, with Gattegno, grade 1 students doing fractions, really, you can see the rest of that clip. It's quite remarkable what they do. And again, it seems to me that's because the symbols are not directly or absolutely tied to the objects, but the symbols are arising out of relationships between the objects. So just to kind of summarize that, these visible resources seem to me to offer a way into working with concepts if what they symbolize is the actions on the resource. So the concrete powerful to the extent it can support awareness between symbols rather than offering a meaning for the symbols. So we're not getting a resource here to say, look, this is 3. You're getting a resource to do something with it out of which that symbol emerges. So what I want to distinguish is these absolute metaphors or representations of concepts with what seem to me what we're seeing in those 2 clips is a more of a relational representation. And what both Bob Davis and Gattegno are doing is setting up these kind of game-like situations where the students are able to play with those symbols. And they don't seem to me too bothered about what the kids understand at that moment. And again, I want to be very careful to distinguish. I'm not here advocating a sort of meaningless playing with the symbols. That they do have meaning. I think that's patently true. But somehow, well, this is the next bit of the clip. This is what I understand by Dictator's quote. The teacher looks after the symbols. The teacher sets up these kind of game-like situations, sets up things for the kids to do. The doing seems critical to me. The symbols arising out of that doing, and the sense will look after itself. It's the student's responsibility to make sense of this symbolism and the link between those concrete objects. And again, the kind of game-like, the creativity seems really important in terms of allowing a space for that sense-making. And I see this as a way through those paradoxes of learning. But you patently, I think, from those clips, don't need to have got somehow the concept already to be able to work with those concrete objects to derive that powerful symbolism. And again, reiterate, it seems to me it's linked to the symbolism coming out of actions and relations. So here are 2 images of ways of introducing early number. This is a resource that's been proved very popular in the UK called Numicon. So this is how they introduce early number. Compared to this would be Gattegno's, a Gattegno image of the number 2, sorry, or the number half. This I'm calling an absolute representation. It's this concrete thing. Number 3 is just that object. And it seems to be, you're going to struggle to get negatives or fractions from this. It's not nearly as easy, it seems to me. And something like this, again, those inverses seem to be very readily there. So what I want to distinguish is this absolute representations from a more relational representation. And of course, the rods can be used in an absolute way, and I've certainly seen that done. That if this yellow rod becomes number 5, then really the resource is not much different from this. But the power of it is keeping the numbers, it seems to me, arising out of the relationships between those links. So what would that imply for other areas of the curriculum? Well, it seems to me it would imply that if you're thinking about, say, area and volume, that you wouldn't be beginning saying this shape is area 4, you'd be emphasizing the relationship between a shape and a unit. And that in turn might imply perhaps working on enlargement before you work on area. Fractions, it seems to me, you would work much more as operators to begin with, rather than as parts of a whole. And again, I think that's there, that that orange rod against the red rod, you can see is the action of taking a half of it. Multiplication and division taught together, if we've got time, I'll do a quick example of that. Another activity that Bob Davis, I know, used a lot in the Madison Project and beyond was the function game as a way of introducing functions. Again, the notation arising out of a relationship, a consistent relationship between numbers. And that's just taking a few. Okay, so I want just in the last 5 minutes to talk a little bit about a project I've been working on, trying to make use of some of these ideas. We're in some primary school, but Bob Davis, I don't think we're talking. There's nothing exclusive here about primary schooling. I think the ideas here are relevant throughout. And I wanted just to offer an activity that arose in the context of this project about multiplication and division that was developed by a group of teachers. The context of this project, I got a bit of money to collaborate with a charity that generally places artists in school to run child-led projects. And we had the idea of, well, what would it be like to place a mathematician in a school to run a kind of project? So I went in and worked with different groups as a sort of mathematician, trying to develop, the idea was to try to develop more creativity in the maths curriculum. So if you're unfamiliar with this chart, how this works, and I need a lot of participation here, okay? I'm going to point to a number, and I hope it's not going to make the screen go forward. It is. Okay, so I'm going to have to try and point to the number just sort of, I'll just go like that. The shadow will point to the number. And you've got to say back to me the number that I pointed to, okay? So we'll just practice that. If I go, right, bit more than that, please.
30.
And a bit more than that even.
40. 400.
Great. And then I can put 2 together, so I can go, and you'll say?
304.
Brilliant. Okay. So clearly with some younger children, there's work to be done just on naming and writing those names. This sequence of activities took place with grade 3 and 4 students. Okay. So I'm now going to point to a number, and I want you to chant back to me, nice and loud, the number 10 times bigger. Okay. So
20. 30,000.
Sorry.
4,500.
4,500. Great. A little bit louder than that, everybody.
60.
Okay, great. I'm now going to point to a number, and I want you to chant back the number divided by 10. That number, whatever number I point to, what's that number divided by 10?
30.
So I'm not going to.
500.
I'm not going to venture to do the
6.
It's too difficult to do the second one.
7 tenths.
Did somebody say 1/7?
Yeah.
7/10, yeah, that's fine. Okay, another point number, could you tell me the number multiplied by 100?
300. 200,000. 30,000.
Okay, and we could do divide by 100. So this was introduced to the class, and the invitation to the class then was to choose any number on the chart and to go on a journey multiplying or dividing by 10 and try and get back to where they started. So I just got a few extracts, and again, if you're interested in this, I think in July I've got some writing about this coming out for the learning of mathematics. So this is an example. The kids were told to take their work when they got back to where they started. So this student started on 500, got back to 500. And we modelled how we wanted them to write that out. So this student trying some, yeah, that was different, trying some similarist journeys. As part of the project, we were encouraging the students to write about what they were doing, to try and pose questions. So I noticed it is clever because if divide by 10, you times by 10 to get back. Okay. So this seems to be a student who's, again, grappling with some quite profound ideas linked to multiplication and division, it seems to me. This student challenged themselves, this wasn't an idea from the teacher, to try and get back in one go. We'd only introduced multiplication and division by 100, but this student had clearly again spotted a pattern, and so it was multiplied by 10 4 times, and figured out they've got to divide by 10,000 to get back. So again, I see in here some sense of this sort of playfulness with the symbols. For multiplication and division, again, are offered as relationships, actions on that chart. We've got a visual resource this time, not a tangible, but the operations of multiplication and division are offered as actions, relationships between that chart, and again, that seems to allow this symbolic playfulness, allow them to begin asking their own questions, but being creative. So, right, let me flip on. So the chart, we also had a version of the chart with the decimals. So some students saw, it was on the other side of the chart, some students saw that and wanted to work with those other numbers. So, and again, seemingly no problem in doing journeys. This was a very, these weren't necessarily exceptional kids in any way. Seemingly no problem extending their work to decimals. I mean, this again is where the understanding comes in. This was, for some kids, their first introduction to multiplication and division. So, what do they understand by that number? Well, probably not a great deal at that stage, but I'm not sure that matters at this stage. At some point, of course, they need to connect that and get some sense of size, but there seems to be evidence here of them, maybe you could see some of the kind of engagement or the playfulness with the symbols through that writing. So yeah, there's this decimal version of the chart, and just very briefly, this work went on for about 4 hours, once a week over 3 or 4 weeks. And after the second hour, one of the kids said, well, all my journeys are just going up and down in one column. I want to do a journey that gets me to a different column. So the teacher and I hadn't thought about this. I'd certainly never used this chart to do that before. So we had to think over that intervening week, and what we decided to offer to the kids was that to get, say, from this number to that number, what you had to do was go back to this column. So if you're at 20, and you want to get to 50, because this is a multiplication and division chart, we're not adding or subtracting here, you've got to divide by 2 and then multiply by 5. Okay? And so wherever you are, you've got to divide to get back there and then multiply to get out. So again, we offered that. I'm not going to model that because of time. And the students were invited to pick a starting and finishing point now and to do a journey between them. So this would be the most basic kind of journey. And some students stayed with doing these ones. 200 divided by 200, 100 times 7 is 700. And the last image of this piece of student work, this was a kid who was seen to be underachieving in the class, but was seen to be one of the weakest mathematically by the teacher. Decided to go from 3,000 to 0.04. A slight error here, but I just see that as the transcription error. And in essence, it seems to me this kid has kind of invented the unitary method, virtually. He's done this transformation in the most efficient manner possible in the context of that situation. Yeah. And again, I see that as linked, I think, to those video clips that we saw. And I suppose there's a few other things to say about that. There doesn't seem to be any difficulty with these numbers standing for operations and standing for objects. So this kind of the ambiguity of mathematical symbolism seems again to I think, perhaps be related to offering these symbols in this relational way. That this ambiguity is there and doesn't seem to be a problem. Okay, I'm virtually there, but I feel it would be wrong to end with the impression this is just about resources or just about representations, because clearly the role of the teacher is very, very significant. Gattegno and Bob Davis were both very skilled mathematicians in the sense of, I don't know, you see Bob Davis with some similar age kids working on the distinction between an identity and an equation. And just the sort of the care with which he does that at age 5, knowing how significant that will be or what he'll be able to do with the kids if they've got that distinction, is linked to their deep awareness of mathematics. There is this allowing the space for the playfulness and the creativity after a very tight beginning. One of Gattegno's image was of a hose pipe that you shove kids through this very structured beginning, and then it sprays out into this space where they can be more playful. And so there's this strange interplay between the formal and the informal, because actually the notation is very formal. This is about getting the kids using symbols and using the correct symbols in a very efficient way from a very young age. In the UK, there's a lot of, at the moment in primary classrooms, about being differentiated, offering different kids different work. And I'm quite struck by how these kids are all doing the same, but yet I see them as all being challenged. Okay. There's one last thing I want to say. Dick Tarter was very clear that he didn't see the example of people like Caleb Gattegno or Bob Davis or himself even as being things to copy, things to claim. And so I think there's also one other very important thing here that, in a sense, if the aim in the classroom is to get kids mathematizing, being creative in the mathematics, the parallel aim has to be to inspire teachers to be playful and creative, to get teachers theorizing their own practice. In the same way that we want students to be fluent very quickly and efficiently in their classroom, we want teachers to be fluent in the way we want students to be fluent in the mathematics, we want teachers to be fluent in their classrooms. And so the challenge, it seems to me, of Gattegno, Bob Davis, Dick Tarter, is not one of copying, but one of seeing from their example just what's possible, seeing how quickly students can learn, and finding what it is we need to work on in ourselves in order to meet the needs of the students in front of us. Thank you very much. So I've run over a bit, but there was a bit of time for discussion. So there's 10 minutes or so for any questions or discussion. Karen.
Well, my question is the Gattegno video. When was that made?
Do you know?
61.
61.
61.
Okay. Why do you?
I was just curious because I guess the Davis one was probably made in the early 50s, and so it was color. I figured it was more recent. There's the black and white. Well, the Davis one came from film. I don't know if the other might have been just video. And I had never seen him. I actually worked with children.
Okay.
I was sharing with Art. That was really lovely.
You can see the whole. I mean, it's on. There's a website called calebgattegno.org, and you can see much more of that lesson.
Oh, good.
It's got a slightly annoying commentary over the top.
Yeah, I was just curious, do they teach more procedurally in where you're from, or do they use more constructivism type of instruction?
Yeah, I mean, it's. I think practice varies a lot from school to school, so it's very difficult to say anything in general. We do get, our inspectorate is called Ofsted, and there are quite a very consistent finding from Ofsted when they go around schools is that they want to see more, they wouldn't use the phrase constructivist, but they want to see more problem solving, they want to see more students talking, and so on. So if you believe that, then it would suggest that there's quite a lot of procedural work going on in schools.
Thank you.
But I think practice does vary. I don't think there's a sort of a UK way of teaching in particular.
I have another question. Do they have an evaluation system then that's similar to what they have here?
Right. Yeah. I mean, schools are inspected every few years. It depends on how well they're doing. The better they're doing, the less they're inspected. And the inspectors would come in and lessons would be graded on a scale of 1 to 4. And as a result, well, I was going to say as a result of that, the school gets graded. But I think it's probably more, many teachers would say it's more the other way around, that the inspectorate will look at the data from the school and decide the grade in advance, and then come in and find some way of matching the teaching they see to that grade they've already decided. It's sort of probably a bit more how it happens. That's maybe slightly cynical, but
It sounds political.
yeah, and then if you're graded 3 or 4, which are the 2 worst categories, then the school can be closed down and taken over by sort of company. Yes.
In your work, is there an element that involves engaging the teachers in a professional development of some kind, or is it more about you're going in and taking on the role of the teacher yourself, or with your colleagues doing that?
Yeah, no, that's a very good question. No, I mean, for me, I'm particularly interested in that professional development aspect. So the project that I worked on, we were working with a group of teachers, and the group of teachers would get together every few months to discuss the work. But I was interested, I was talking with Karen about this yesterday, but I think, and for me personally, it seems to me unless you see kids operating like they were operating in those videos, I don't know how you believe it's possible, because it seems quite different. You probably wouldn't have experienced that necessarily growing up, and so I think there did seem to be something quite. I felt quite uncomfortable in a sense taking on the role of teacher because my focus was much more on the professional development of the teachers. I've increasingly come to think that there is something powerful about it. If it goes well, and if the class get engaged, for people just to see with their kids here and now just how mathematical the kids are able to be, and I think. I mean, some of the previous work I've done has been about listening and hearing, and I think that's a really significant part of what's going on, that it's teachers giving themselves permission to actually take account of what the kids are saying and take it seriously.
In your professional development that you've done so far, or in the future, are you planning to, if not, you haven't already, use video clips of kids engaging in these kinds of activities?
Yes, I unfortunately just had a bid turned down where that was precisely the aim, was to try and get some quite extensive video clips of that happening. I've got another couple of bids that we're working on, and we're trying to develop a sort of some activities to have quite widespread use in year 2 of the project, and certainly in year 1 we would want to take some videos of lessons. We didn't, particularly on the project we've had, because the focus was more on the teachers. But no, I think it's really significant. And I think it's not quite the same as seeing your kids acting differently and seeing somebody do something in your classroom.
Yeah, you started by pointing out the importance of the lingual part of math learning and the math discourse. But through the examples and 2 videos and your example, it seems like it's somehow a discourse between the teacher and students individually. Where do you see students discourse based in this in math learning?
Yes, I think that's a really good question. I mean, I guess that the I don't know if that hose pipe image made sense to you in terms of what might be going on in the classroom, but we saw in all three, we saw that the hose pipe bit of the activity. So there's a stage where the teacher is setting up this context and setting up the symbolism, and only the teacher knows what the correct symbolism looks like. So I think the discussion has to be very tightly controlled and tightly moderated by the teacher to make sure the symbol use is correct. And once that's been established, then there is more space for the peer-to-peer conversations. And so, for example, in the project that I was working on, one thing that became quite common across all the teachers, not when I was there, this is sort of stuff that they did themselves, was that at the end of a lesson, they would leave maybe 10 minutes, and they would all sit on the carpet, and they would have a chair at the front, and different kids would come up and talk about what they discovered or what they found out, and the other kids would question them and raise more questions from that. So, I think there's something very important, but maybe not right at the beginning of setting up an activity. I'd be interested in any reflections on this kind of absolute relational representation, whether that distinction makes sense or seems useful.
Having worked a bit with Cuisenaire rods and videos from a classroom-based research study about Carolyn and others modeling of the rods and how teachers learn from this, I think there is something very powerful about this notion about providing an opportunity for people to build a relational understanding about number. Not only values integers, but the whole part-whole relationship and what may be in working with the Cuisenaire rods in particular, by having a permanent number name, a permanent color name to the rod, and have that sort of be a reference is something that really reinforces the development of a relational understanding of number. Because from this fourth grade classroom study, there is evidence of students' reasoning where they are making use of this relational understanding of number to solve novel problems. And to me, that's something that's pretty powerful to develop in a student because of how useful that will be, that kind of thought process that's going on. And so, I don't know, I'd be one to advocate for more of that, working with younger children, where it seems like currently the curriculum is sort of more focused on developing this absolute sense of number, which, I don't know, it might be something that interferes with a subsequent developing of the relational.
Yes, no, I'm sure. I think that's right. I mean, and I guess I quite deliberately chose the word relational representation rather than relational understanding, which obviously scans it, just because I think what seems powerful about relational representation is you can do it from the beginning. Right from the moment go, you can be operating with a relational representation of a concept without necessarily, the understanding. This is, I guess, what I'm saying. Can come along behind. And I mean, I've recently been collaborating with a neuroscientist in Canada who is suggesting that he's got neuroscientific evidence that exactly what you said, that these more absolute conceptions of number are not, when you're working on arithmetic, you're not activating the same bits of the brain compared to if you're thinking about number in an absolute sense. You're doing something different. And so, particularly for those kids who then struggle in maths, all they get probably is just more and more absolute representations of number, and that may be reinforcing the very kind of system that they need to get beyond to access higher levels of the curriculum.
So yeah, I guess we're out of time. Thank you, and you'll be around if anyone has any questions. So thank you.
Thank you.